Yeah, so this is our work with all the people who are here. So I already presented Arto about his presentation on how the TLS can be married to PEs and more precisely about the remote attestation part. And then Hans presented some of his works around RFC. So there is a RFC also which is related to this attested TLS work. And then Thomas was talking about some of the core problems of verification, and this is one of the problems that we were looking at. The roller coaster ride, I will explain a little bit later about this. So this is interesting journey that I would say we had over the period of time, and so when we started with TLS, which is already like has been explained a lot. So the core idea basically is that TLS can itself not be sufficient, and we need some additional mechanisms of that. So I will explain a little bit about how remote attestation at a high level combines together with TLS to overcome this. Then we have then I defined the contributions that we had in this specific work, and then the approach and the tool that we use for this problem solving, that's already defined, like also explained about covariance, so that's exactly the tool that we use. And the two main contributions that we have are the validation of TLS 1.3 and the formal analysis of a tested TLS. So that's what I will explain and then finally summarize. Okay, so TLS, as already explained, so it's the world's most used cryptographic protocol, which is used in our daily life, communicating with, even for this conference, like data is communicated over TLS. And conceptually, if we think technically about this, this is basically consisting of two main sub-protocols. At a high level, it's consisting of handshake protocol and the record protocol. And handshake is the most important part of this whole thing, where the keys are established, and based on these keys, basically, we are doing the rest of the handshake. For instance, like the first part, which I have here, although the RFC for TLS defines like three parts, I try to combine them together cryptographically, what makes more sense, like unauthenticated key exchange, while the RFC defines this parameter negotiation as a separate part, but I think it's more logical to say that there are two parts, which is unauthenticated key exchange, which is going on here with the client and server, and Arto nicely explained it yesterday. So also the parameter negotiation is, I consider it as a part of this within. So it's not, let's say, a separate part of parameter, server parameter or something like that. Logically, I would think it makes more sense to have it as one part. Anyway, so this is unauthenticated, and then the authentication, including the key confirmation, which is this also called sometimes the proof of possession, comes from the second part, which is labeled here, like from the certificate onwards up to the client finish, when both parties have finished checking their log of the messages that both server and clients saw exactly the same sequence of messages. And via HMAC, they can, via the HMAC here, they can ensure that the log that server and the client saw is exactly the same. So that's how somehow the overall idea how they get together to see that we saw the same message and there was nobody in between of us. Okay, so that's the core idea. And one thing that I want to highlight here in TLS, so the security argument here is based on the protection of this key, which is the long-term key of the server, assuming the server as the authentication party. And then if this is leaked, all the security of TLS is broken. So this is the only thing that it's the security argument completely is based on this, that this key is protected. That's the security argument. But the problem then is that we don't only need, how do we actually ensure that this is protected? This key could be leaked, this could be available to others, like what's the environment in which, how is it protected exactly? That's a core question. So there is no validation of security state of that endpoint software and the platform. And for many use cases, including the confidential computing that some of us also work on, we need a more comprehensive set of security requirements in that case, that we want assurance not only of that key, but also the environment in which that software is, whether it is being protected or not. That's the key problem. So another problem is the complexity, which in our opinion at least is a problem that that I will justify a little bit late. And Wasan nicely also explained that there have been 15 different exploits, and between each exploit there was a proof. So that story somehow also relates to this, that can we formally justify that this complexity is really required? Is it? So there are some interesting things that I will come back to in this. But the main point here was that the security environment of the TLS stack, like the server or the endpoint, so of the endpoint, whether it's the client or the server, whichever side we are authenticating, is not there. And remote attestation can help in this regard. As in, just to give you a reminder on this, there have been many talks. So from the IETF perspective, like REDS standard, there are three parties, but just to boil it down to two parties, protocol like attester and the verifier attester running in the cloud, for instance. And attester is the entity which is under test. So this is generating some kind of an evidence based on this attester request, sending over the evidence, and then there is a process of verification at the verifier end, and the verifier then sends over the secrets. In this case, if that is the use case, that's dependent on that specific use case, or it could be any sensitive data. So that's why I labeled it as feedback. And I presented in the last meeting last year our work with Thomas Mosati and Simon Frost and Shenzhou from ARM, that we had verified this two different architectures of intermediates, the remote attestation mechanisms in these. And so I will not go into the details that this table shows. So the only point that I need for this specific talk is that authentication is not provided by any of these PTPs. That's the key point itself. That would be sufficient for this talk. And the second problem with remote attestation itself, if we see it in isolation rather than as a combination with TLS. So in isolation, remote attestation, currently there is no standard way of implementation. The RAS architecture at a very high level says, hey, this is the verifier, this is the line party, this is this, but that doesn't define any protocol. How do they actually send over the evidence, what is contained in that? So, and what's the attestation result, how the things are matching together. So there is no protocol. So apparently, like, it's protocol agnostic, designed to be like this. But okay, so how do I use it in the real world? What's the kind of protocol that in the end we need some protocol, right? So we don't need the theory that these are the three entities, they go there, and this is the thing that happens. So that's currently there is no standard way of implementation of remote attestation in isolation. And that brings me to the combination of the two. How do I think about both of them together? Coming back to Arthur's point, can the two marry each other, or will the marriage lead to something fruitful for this, or will it be, let's say, creating more problems or more challenges? That's the next topic. And Arthur already explained this. Is just a reminder for this. So if we marry them together, the two things. So there are three possible ways in which we can, let's say, marry them. So this is the pre-handshake attestation, in which the attestation evidence is generated before the TLS handshake starts. That's called the pre. That's why it's called the pre-handshake attestation. And in the intra case, that is, the evidence will be signed within the TLS handshake, and more precisely in the authentication part, as I defined, like the two different parts of the handshake: unauthenticated key exchange and authentication. And finally, the post handshake, which means that the TLS handshake has now completed, and then the evidence is signed. So the three different classifications, I really like this way of thinking about this, because it will help us maybe not verify each and every protocol, rather maybe verify one protocol and the rest of them can actually see the same and reuse the many of the things that lie, for instance, in the pre-handshake attestation. So if we verify one in that, or maybe we generalize it later on. So I think we cover more rather than just verifying each and every of these points, protocols. Okay, so one of the most commonly used among pre-handshake attestation is the Intel's RATLS protocol that's proposed by Intel, and it's used in many different projects. For instance, Grameen, RATS TLS, Open Enclave, attested TLS, and STX SDK attested TLS. And I really want to show this how Intel presented it in their paper. So this is the white paper which is referred here. Thomas North, who also used to be at our chair here in TU Dresden as a PhD student, is now at Intel. So this is, the left side is showing the remote attestation. The paper is titled Integrating Remote Attestation with Transport Layer Security, TLS. And this is how the integration is shown. This one side picture, this one side picture of TLS. And even for TLS, you see that this paper was in 2018. There have been no upgrade of the specification whatsoever after that. And just to remind you, in 2018, August, TLS 1.3 was already a standard. It was an RFC. So this is one of the challenges, as others also highlighted, like the protocols are really specified in a very ambiguous way. Like I don't want to, at this point in time, 24, I wouldn't like to, and even it's not recommended no more, it's not recommended anymore. We use TLS 1.2 for the new applications that we develop. So the specifications really need to be updated. This is having still in 2024, TLS 1.2 specs is still a bit strange for us, that how do we go about the formalization of this? And the paper titled Integrating Remote Attestation with TLS is not really describing how exactly I am integrating the two things. It's just putting in two things, separate things. Hey, this is remote attestation. This is how it works. Okay, we have already formalized it. This is how TLS works. We thought, okay, so TLS is already formalized for many years, like 5 years at least, and even 6, I think. So what people should have described was actually the integration, the real integration. I mean, how is the evidence, at what point in time is the evidence generated? At what point in time is the evidence transmitted to the other party? And what proceeds, what are the real changes to the TLX specs that are changed? So this was the real question that I would expect a paper titled integrating remote attestation with TLS to describe. But anyway, so here comes our contribution. Starting with that, what we started was, we thought, as I described, like TLS has been formalized 6 years ago. Remote attestation we have nicely formalized, which I presented in the last meeting last year in Romania. And the idea was that, okay, so we can directly use it. So we can directly combine the two things together. It should actually logically work. There shouldn't be so much effort there. But by going through this process, we saw that the validation of the TLS 1.3 key hierarchy was not properly done. I will explain what I mean there. So we found like 3 major issues in that. And secondly, so just to clarify, the first goal was, the first contribution was not our goal. We hope that like 6 years it has been in use, it has been verified and so on. It would have been nice to just to integrate it together. This was just after exploring, we found that actually there was no validation or no proper validation performed for this. So the second contribution was our main goal, which was that we wanted to formally analyze this and to see how the attested TLS can be used for TEs. There is a related work which integrates attested TLS and formally analyzes it for the TPMs, but there has been no work for the TEs. So this was our main contribution. The approach and the tools that we used have already been nicely explained before. I will just quickly remind you of the two things, symbolic and computational model, and more precisely I will focus on why this was relevant for our use case. The symbolic provides a reasonable level of abstraction, and what I mean by reasonable is that it's reasonable for my specific case study because these protocols keep changing, and doing a computational proof would like take some years in order to do that. And this confidential computing field is evolving so fast, so the protocols are developed and then started and so on. So this process is going very fast. The field itself is really in its infancy. It's not a mature field that I would call it. So that's why the protocol, I believe that symbolic is the right way of abstracting this and verifying this. So that's what I call as a reasonable level of abstraction. And as Vasana also nicely explained, like it's for unbounded number of sessions, which is, or it can be like the code itself can be unbounded number of sessions. So there are some rules which are not, but I write it from the tool perspective that I have used. Anyway, there are still some limitations of symbolic. It's non-probabilistic model, as I explained. It's at some future stage it might be done, but the field itself is not that mature to go towards that. And some side channels are considered here out of scope. Tool used in probability based on applied by calculus, nicely explained yesterday. And one thing in our mind in selecting this tool is that we might in the future go towards computational proof using cryptography. And the nice thing about cryptography is that I can reuse some of the work that I, let's say, developed in this into that computational model to verify it. Okay, so very simplified approach, high level idea. I have the specs like any formal model, formal verification thing. So from the specs, we have the formal model and the properties, formalizing them, doing the formal analysis, and based on that, either we will have a proof or an attack. Pretty much standard thing. And the important thing I want to talk about here is the validator. How nice is your formal model relative to the actual thing that exists? Because the actual thing is the one, the thing that we actually want to verify, not the kind of a toy model to work with. Toy models are nice to get started, but that's the real objective of what we actually want to gain out of this. So comes now the roller coaster part. So when we started diving deeply into it, we saw, as I also explained, like there were incomplete and outdated specs for RTLS. TLS 1.3 is no longer proposed to be used, so it was still based on TLS 1.2. And as I already explained, it's an RFC since 2018. Okay, the fix that we applied here is that we used an implementation, which means that code which was available from Intel, we saw some of the things that how they have actually done it to fix and to complete the specs. And community input, I will come back to this point a bit late, but we reached out to many people to see like what exactly or how exactly is this being done and what is the intuition behind this and so on. Not only from TLS perspective, also from RTLS perspective, like confidential computing consortium as attested as one of them. So another issue that came up was when we started. Okay, as I said, so we focus on India's these artifacts for TLS. The other part about attestation that we have already have, so combine them together. To get started with that, we saw that there are really very few comments in the code itself, and to verify like huge code base like TLS protocol without comments is itself a challenge. Like how do we even get started with it? And the compelling paper also doesn't explain a lot about how the choices were made for the design of that provided code. And literally no comments inside the main modules. Literally no comments. So that is really amazing that the client want to, server want to, so that is modeling like the TLS 1.2 version of the client and the server. Client wants three, server wants three, so really no explanation of what is going on. So this was kind of really shocking to me at least. How do we use these kind of standard protocols as and where is the reproducibility factor where we have no guidance for the let's say for the community how to use that or how the decisions were taken, like what were the challenges that were or how to why exactly this specific model and not some other way of modeling it and so on. Okay, coming back to the point of validation, which I will also explain a bit later in more details, but the point here was that there were two different code bases for that, so draft 18 and draft 20 in India's repo. And for draft 20, which is the most latest one, of course, what we will go for that as everyone else has done, also including the learning. Recently, last year, did some verification based on that, and everybody else is using this. So the fix we applied here for this validation was that we designed our own validation framework, which I will explain for the fee schedule specifically. And yet another issue that we faced was that we understood everything, what is done roughly like as far as we could. We now started extending it with remote attestation that this is okay now under our control, the artifacts, how they are working, and now we started putting attestation part into the artifacts. And what happened was that a simple extension like just putting one signature on, generating one evidence at the top and putting it over, allowing it to be replayed across different sessions, didn't finish in 1 month on a big high server Ice Lake that we have in our chair. And then we submitted it to the program developers for analysis of this. We didn't get any feedback back. So the fix here was simple. We couldn't do anything else other than developing it from scratch ourselves, rather than just waiting forever for the response. Of course, we understand like they are also academics, they have their own priorities and deadlines and submissions and so on. But my point here is that about again the usability perspective of that, as Giorgio very nicely mentioned, that rather than like having people send you emails or hey, I'm facing this problem about this, or how do I fix this, or I'm doing this issue, why not we have some better usability perspective of the things and we make the tools such that if we invest a little bit on that rather than investing every time on tackling the issues or emails like this. So what we did is the final approach is in this slide. What we added here, coming back to my point on community input and the implementation. So the specs for the form model itself does not come only from the specs, it also comes from the implementation and community input. And security goals are formalized as properties. There are many like back loops in this. For instance, like form model will specify, also change the specs and so on. So many things will actually change. For example, the TLS 1.2 specs, we throw it away. We start from TLS 1.3. That's a natural decision. So this figure is only supposed to be read like one way. There are many loops back. So the specs were not the original paper, but the specs that we have now are, of course, different from the ones that we started with. And then the validation part that I explained was not done, so we added that validation part and update the form model based on that. And this was nicely explained yesterday, the 3 possible outcomes, and we added the 4th one, which is that no result, like the one coming from the 1 month server running forever, just generating the horn clauses and just showing that okay, horn clauses have been generated, this much horn clauses have been generated, and forever, like will it ever stop? So how do I know that it will stop? How do I like get a definition? I started first on my own laptop, this nice laptop that we are using for this conference, SGS protected version 2 decaf enabled. The TLS only takes 5 minutes on this laptop. The original, I mean, the India artifacts only take 5 minutes. Okay, I said, okay, let's wait for like 1 hour, 2 hours, 3 hours, and so on. And when nothing worked, like maybe I left it working for the weekend to work on this, and then nothing worked. So let's try it on the server now. So the thing is working because I was expecting like 5 minutes before, and now we have the so much increase in the time, so it shouldn't be, I was not expecting a lot, and as he explained, like the evidence generated, and only that was the change that we added to that, so it was, to us at least intuitively, should have been able to be detected. Okay, so I think I'm running out of the time, so the chair is there, so
No, it's, I mean, you have 10 minutes and then
okay.
5 more questions.
Okay, sure, right. So quickly glancing over the 2 contributions, just to give you an idea, I'm happy to explain or discuss offline. So the validation part, the first contribution, what we have here is the all coming from the TLS specs, nothing that we added, we just nicely just displayed in different colors. Starting from the pre-shared key as the input key material and 0 as the salt from top. So there are three stages that are kind of symmetric, and then the fourth stage does not have this HTTF extract. And this is showing the outputs coming from these functions. This is showing the key schedule from the RFC 8446 7.1, but is not the complete picture. It only shows you, or let's say with this part, the left side of what I'm showing here with the mouse. And the right side, we added on different sections like 4.1 and so on, different, it was scattered around in different parts. So nothing really that we contributed to this, but we just nicely have it in front of us. Okay, so this is what we actually have, and would the formal model actually will be replicating this or not? The validation of the key schedule, this is really our contribution, that what we did is we applied state-of-the-art AI ML models to do this, and that state-of-the-art model is simply a equality comparison between the two, which is that the India artifacts and one coming from each and every key coming from the India artifacts, and each and every key, the corresponding key coming from the TLS specifications, we see that whether the two match or not. So that's the simple logic for this. And if they match on a different channel, rather than the one between the server and the client, on a different channel, completely different channel, we send over these two constants, which are the success and the failure. So if they match, we send a success. If they don't match, we send a failure. A very simple, really naive kind of way of validation. By the way, if you have suggestions on improving this, you are very welcome. But even with this naive kind of thing, we saw that so the first two are successful, the third failed, then success, and all of the rest are failing. When we see the logs for this, what happened exactly, why was the difference, we came over with this, that this salt, which is the first salt for the handshake secret, instead of having a 0, which was according to the TLS specifications, they were actually using a hash over the 0. We saw that, okay, so maybe they have changed the derived secret function internally, but this was not the case. A similar example for master secret, exactly same problem. And finally, the third issue, from the TLS specification, this was supposed to be done, IAM being the 0, the salt 2 as an input coming from the derived secret into the HTTF extract. But what the artifacts had was actually this handshake secret directly input to the as a salt in the HTTF extract. And this remained very confusing for me for a long time. Like they actually generate this salt too, and due to some weird reason, they have like not used it at all. So they generate it, and then I was thinking, okay, so was this really a mistake? Why would you generate this? So if they don't input this to this, there is no other usage of this salt. That's the only purpose that it solves. So they actually generate it, but they never put it as input to the HKDF extract. So quickly just describing, we also ruled out the abstraction. That was a natural next thought. Okay, so maybe they are doing it because they have applied some abstractions, which for us pretty much ProVerif as a black box, that it is maybe doing something which helps ProVerif do it in a very fast way. But that was not the case. Like you see a very negligible difference. Even in one case, it was a bit faster. Of course, like this is taking into account the salt from the OS, what workloads were running. Anyway, so we didn't find any significant difference between the original India artifacts and the three fixes that we applied individually, and the three combined together. There was no difference in the abstract, or insignificant difference in the timings. Community input, coming back to this point. So we contacted the paper authors for this, which was published in 2017. Bruno Planche said I was not the one who was coding. Karthik is, or at that point in time, was busy with his startup. Nadeem never replied to us. We contacted also one of the authors of Blur, who was actually working on the same artifacts. He used it for his own purpose, extended it. And so he also didn't know that actually this was wrong. So we went over to the TLS working group. We described, hey, this is the problem. We didn't explain the problem, so we said, okay, so what is the purpose of this thing which is lying there, like the dive secret? What role does it play? And the response from the working group was, hey, look at that paper from India that nicely explains what this is going. Okay, I said yes, I have read that paper. That's why I'm asking that in the artifacts, they have actually not used it. What really is the purpose of this? And then there was a complete silence on TLS working group. Okay, next step, we went over to the usable form methods chairs and asked them, hey, you have an opinion on this, why this would be the case that we have it here? No response, or no opinion, I should say. So they responded, but they said, okay, so we don't have any opinion on this. CC attestation sake, we explained it over there and so on. So many things. Last week, we also presented at the IRDF Crypto Forum, a research group at IEDF meeting that was last week. Still like no real opinions. So for the time, I will skip over this part and or maybe just quickly show you this that we applied in the headcount check model. And the 3 steps here, the next, so this figure is showing the changes that were made from the original TLS to the attested TLS protocol. And the property that we verify is the replay protection property, standard way of formalizing it, nothing fancy here. The main contribution is really formalizing the protocol itself and nicely representing it in ProVerif. And ProVerif then explains us that there is an attack that two different sessions of the two different instances of the verifier can then actually replay the same evidence with the same malware. Okay, to conclude, like Intel's RTLS is potentially vulnerable to replay attacks. That's what we showed here formally. And there is a need to formally verify and standardize these attested TLS protocols. So India's model is wrong that I have explained. The 4 lessons learned in this actually come from all the roller coaster thing that I just explained. And the plan is to, so currently we have it for the server side. So server as the attester, we can go towards this client side, which is very interesting from Huawei and other partners. And we propose, so the next plan is to propose and verify the fixed version of RTLS without going into the intra and the post handshake. Can we really fix the pre-handshake attestation protocol itself? So that would be without changing the TLS protocol stack, I mean. So that would be really an interesting thing that we are planning to do. And the call to action is that if anybody is interested, please very welcome to join our work. And thank you very much. Sorry for running late. Yes, please.
I agree with a lot of the comment.
I suggest to take one quick question and then we move to lunch and continue conversation, long conversations during lunch. Okay?
So
Because no, just because we've accumulated 1 hour of delay and it's better if we.
There is a mute button you need to unmute. Okay.
So I agree with a lot of the comments you made about the
Yeah.
when I work with CH, we started from this stuff. Have you had a chance to look at the model we did for TLS CH to see if the comments you had there applies also to them? Because I remember for mostly the TLS step. And second, with respect to the time, not to them. But at that time when they developed in 2017, and there was not yet the new version of the it has massive scale.
Yeah.
And so I think from their code, it was taking instead of 5 minutes that you here, it was taking I think like between 11 and 12 hours. So on the 2.2 version of Powerade, probably a small change would have made a difference. Not on that version, but
Yeah, sure. That's something that's in plan. We will also verify it on the actual version that they had. The paper itself, I believe, if I remember correctly, does not explain really which version did they use. But I think it would be easy to find which version was available at that point, the latest version that was there. So this is something that we can really add in this table, that's version. And the first point was that about your own code about ECH. I had a look that's nicely commented, so I really like that. But the reason why we didn't go towards using that rather than this was we had already started this work when we were aware of this, that we also have this. And the second and more important reason was it has a lot of complexity. The ECH itself, there are a lot of things, so the validation part itself will become too complex. And having that complexity for a simple extension like this, at least, I think it's not maybe, or I'm a bit worried that it might, okay, so first I need to understand that what exactly was going on there. So how are the choices made? And ECH is now adding this, do I need this, which configuration do I need? It might work for my configuration, but it might not work for some other configuration. So there are many things I think we need to understand in that code before we can actually start using that code. So there are this kind of issues there. So, and would it still remain compatible with the future extensions that we do? So I believe this was the right selection at that point in time, but I do not see anything additional that we can add from that to this. I mean, seeing the data from that piece of code to this piece of code, it's already incorporating like all the keys into the form model. And yeah, so that's the basic reason why we did it. Yes, please.
I was following up about this one side. I was wondering whether we should brainstorm a little bit on how to sort of build a more solid foundation of these tools and the artifacts going forward. Because if we indeed sort of go forward with standards organizations relying on these tools or making them a prerequisite, I think we should have like maybe more funding, get more funding for supporting the tools because we rely on them, and also making the artifacts available and maintain them properly, document them, provide some design rationale and so on. So because that's an investment that will pay off in the future for the work we do afterwards with the next version of the protocol.
Exactly.
That's it's fun.
I completely agree because this, I think rather than ECH is also nice, like that's one extension. What I proposed to the TLS working group was we should have a baseline TLS, which any extension can actually use. And we have many eyes looking into this, validating it from any perspective, like the validation we did, some other validation. So that piece of artifact should be, let's say, really the standard with the standard RFC, that's the standard, let's say one standard for Proveric, one for Tamarind. I don't say just for Proveric, but for one for Tamarind, one for many other tools. But that should really be the one that's, if I want to extend TLS somehow, I should not be really like looking like, okay, so there are now 10 available artifacts, which one I use? Which one is good for me? Going about understanding that. So it's nice, I think, and very useful that we have one baseline for each tool at least, that one can use for any extension that's possible, rather than having for each extension separately or doing that. I think that baseline effort will pay off in the long run for TLS. We have many extensions coming up, PQ extensions, AEs, and all that stuff. So we I think one baseline which is well understood, well commented, well documented, and everyone can then, and well looked up by the experts and also by the developers, and everybody agrees to that, and then we build the community from there. I think it would be a very useful effort in the future.